Okay, now members, let us see how you go about this question here. It's saying still there are still on traditional forces acting on a polygon. So what we have here is ABC is a rectangle with AB 1.5. So read as a summarize. So let us first mark our triangle, our rectangle. This is A, this is B, this is C, and so that will be our D. So I think that's that. AB is 1.5. This is 1.5 meters. Then AD is 1 meter. So they are giving us now the length or the dimensions of that rectangle. Forces 2 newtons, 1, 1, 4, and 3 act around AB and AD respectively. So we start with the AB. AB, the force is 2. So now this is a force. These were dimensions, but now they are giving us forces. So this is 2 newtons. Then they're also giving us BC is 1, BC is 1. I think it's the direction 1 newton. Then CD is 1. CD is 1 newton. Then BD, where is BD? DB is 4 newtons. DB. So then we're going get our dB there. Our dB is there. dB is dB in that direction. So this is our dB. The other than us is 4 newtons and 3 newtons at along AD. AD is having 3 newtons. So we have finished that. Okay. Calculate the magnitude and direction of a single force that will replace the system of forces. It's important they're asking for the resultant force of the whole of these forces. Now, what we do to get the resultant force, we need to always put all the forces in the x component, the total, we get the total, and also get the total of all opponents in a vertical order. So what we are going to do now, you see, we have only one. This is purely vertical, purely horizontal, but we have this force which is not pure horizontal, neither horizontal nor vertical. So what we need, to resolve this force, we need always this angle here. So what am I going to do? So now I need to get this angle. How am I going to get that angle? To get this angle, we need the sides. Now, the sides, we need the dimensions to get this angle, not the forces. So people make mistakes here. They come and they use these forces. No, to get this angle, we use the dimensions given. So now I'm going to take this triangle here. So if I take that triangle there, this is how it's going to be. So let me call this theta, because we need always the angle is horizontal before we. So the dimension here, this is our theta. This is going to be D, C, B. Remember, if this is the rectangle, this side is equal to this. So this is going to be 1.5 meters. And then this one is going to be 1 meter. This 1 meter, because this side is going to be equal to that side. So there, what do we have? So it's that I have this, I have also that. So there I'm going to use tan. So my tan, theta, is going to be opposite, over, and adjacent. And so this one is going to be, this is going to be 1 over 3 over 2. Because 1.5 is 3 over 2, which would be 2 over 3. So now if I have this, remember, to resolve, we need always the sine theta and then the cos theta. So from here, you can start now, my tan theta is 2 over 3. So how can I get the sine theta? Immediately I come and I draw my rectangular triangle here, like this. So if I have this as theta, this one is going to be the opposite to, this one is going to be the adjacent. How that write the hypotenuse? It's going to be the square root of 13. Why? The hypotenuse will be the square root of this squared, 3 squared, plus 4 squared, which will give us root 13 with ease. So meaning that now our sine theta, which is opposite over adjacent, over hypotenuse. Then the cos theta, our cos theta here is given by adjacent over hypotenuse. So we have got them. Now we can easily resolve this triangle, this rectangle here. So now, how am I going to resolve this? So if I'm to maybe an iron rate, it's going to take, time. Let me redraw it here. After all, you need it. So if I'm to redraw it here, so now I have my A. Now I name all the forces B, C, B. So this is going to be 4 newtons. 4 newtons, 1 newton, 1 newton. This was 3 newtons. Then this was 2 newtons. Now, you see now to resolve this force, this one here, to resolve this force here, I'm going to go like this, so I'll go like this, then I'll come like this. So to resolve just this force, if I'm to pull it out here, this is the force I have there. This is my force, which is 4 newtons. To resolve it, remember I have my theta here. I will go like this, then I'll come like this. So it's that now, this one is going to be adjacent. So adjacent, this one is adjacent. So we shall get now 4, the force, then cos theta. Then this is opposite, we shall get 4 sine theta. So see the direction there, you have to be careful with the direction. So, meaning, if I'm to resolve this, my x is going to be in that direction. First of all, I'm going to be having 2, then plus. This is going in that direction. This one is opposite, so minus 1. Then plus. You see this one is going in that direction. 4 cos theta. I think there in the other force, we have this one. We have this one which is opposing. But we have this. So, which will be 1. Because this is giving us 1 plus 4, but now our cos theta was 3 root 13. So we come here and we get our x there. So here I'm getting 4.328. 2 newtons is. Now, after we come and also now resolve. You see, we have this, we are going now to resolve also that's those systems of forces. Now, resolving them vertically. So, we never resolve vertically, in simple terms, we are getting now y. Start with those forces which are acting in that direction. We have 1, this one, then we have that 3. Is there anyone which is opposing? Yes, the one which is opposing, then plus a negative 4 sine theta. And so our y will be, this will be 4 minus 4. Now our sine theta was 2 over root 13. And so our y here is going to be 1.781 newtons, and that is R1. So remember, always R resultant, FR is given by XY, which will be now our 4.3282, then 1.7812. These are newtons. Now, if you want to get now the magnitude, of this, the magnitude of this, and simple is that when I try, all of them are positive, so x is positive and also y is positive. So this is the resultant there. So this is my FR, this is the arm alpha, the direction, this first is 4.82 and this one is 1.7812. So it's that now our FR, which can get our FR by easily getting the square root of now this so our FR is going to be, when we put that on the calculator, so I'm getting 4.6804 newtons there. So that is the resultant force. The magnitude of the resultant force is this, but now its magnitude is that. Then the direction, let us call it alpha. Direction is going to be tan inverse, say the opposite, 1.7812 over the adjacent, which is 4.3282. So our alpha here is going to be here I get straight to 0.44 degrees. And so now you see it's acting to the side. You see the side now. That's why we say the resultant force, the magnitude of resultant force is this, acting AB. As simple as that. So you see here the magnitude of resultant force. Resultant force is 4.6804 newtons acting at 22.44 degrees to AB. Why do we say B? Because our AB is the horizontal. Our AB is the horizontal. Because it's that acting that. Or we say acting to that force. So that's it. That's why you had that. Now we are going to see ideas like those ones of hexagons. So we are going to see now how to resolve components of forces for an hexagon. See in that lesson. But please don't forget to subscribe to the channel. Always visit the playlists to look out for the topics you want. See you there.